This lesson is linear equations in one variable. This is section 2.1 in your textbook. The essential question for this lesson is, what are linear equations in one variable and how do you solve them? So what exactly is a linear equation in one variable? Well, first of all, remember what we learned before, that whenever we have an equation, we must have an equal sign. If you don't have an equal sign, it's going to be an expression. So we have to have an equation, and the equation is going to be in the form ax plus b equals c, where a, b, and c are real numbers, a is not equal to 0, and x is the variable that you're looking to solve. Now, this linear equation is also considered to be a first-degree equation, since the greatest power on the variable is 1. So there's no x squared or x to the third. So this is a first-degree linear equation. Now, a specific example of a linear equation in one variable might be 5x plus 2 is equal to 17. Notice, in this case, we have a is 5, b is 2, and c is 17. And we have just the power of 1 for the x. So this is a linear equation in one variable. Now another linear equation in one variable might be x is equal to 3. Now, if we look at these last two equations that I've mentioned, notice the one on the right says x equals 3. Well, if I plug in x equals 3 on the equation on the left, I've got 5 times 3, which is 15, plus 2, which is 17. So these two equations are equivalent. Or another way of looking at it is 3 is a solution to the equation on the left. All right, another way of looking at an equation is to use the analogy of a scale, a balance scale here. Okay, and the scale is in balance so long as there's the same amount in each pan here, on each side of the balance point. So when there's the same amount in each side, then it's in balance or it's equal. Now, as soon as I take something out of one side but not the other, then it becomes imbalanced. So just like a scale, an equation, you have to take and do something to one side, you must do the same exact thing to the other side. So if I add something to the left, I've got to add something to the right. Or if I subtract something from the left, I have to subtract something from the right. So whatever I do on one side, I have to do on the other side as well. Okay, so now let's look at our original equation again. 5x plus 2 equals 17. Whatever I do on one side, I must do on the other. Well, I'd like to get x by itself on the left side. So initially, what am I going to do? I am going to take and get rid of the 2 on the left side by subtracting 2. But if I do that on the left, I have to do it on the right as well. Well, now your result is 5x is equal to 15. Now, I want to get x by itself, so I still have a 5 in front of it, so I want to get rid of that. So I am going to divide by 5 on the left, because 5 over 5 is 1. But if I do that on the left, I must do the same thing on the right. So this really yields our final solution of x is equal to 3, okay, which is the solution for this equation. So here we have treated this like a scale. Whatever we did to one side, we do the same thing to the other until we worked our way down to having just x by itself on the left and 3 by itself on the right, which is x equals 3, which is the solution to this equation. So now let's look at another example, okay? Let's say we've got 4x minus 2x minus 5 equals 4 plus 6x plus 3. And we want to solve this for x. Well, what are we going to do first? Well, the very first thing you need to do is to combine like terms, which leaves us with 2x minus 5 is equal to 7 plus 6x. Now we're going to want to get the x's by themselves on one side and the numbers by themselves on the other side. So what are we going to do here? Basically, what we're going to end up doing is subtracting 6x from both sides. So if we subtract 6x from the right, we're going to subtract 6x from the left, and that's going to result in minus 4x minus 5 equals 7. Well, now we want to get the 5 over on the right and get it away from the left side, so I want to add 5 to the left and add 5 to the right. So if I do that, I've got plus 5 on the left and plus 5 on the right, which is going to yield minus 4x is equal to 12. Well, now there's only one last step that I have to do, and that is to divide both sides by minus 4 to solve for x. So if I divide the left side by minus 4, and I divide the right side by minus 4, I end up with my final answer of x equals minus 3. Now I can go back and check this on the original to see that it is a solution, but I think you will find that this is a solution for this particular equation, 4x minus 2x minus 5 equals 4, plus 6x plus 3. Now let's look at another example. Okay, let's say we've got 2 times x minus 5 plus 3x is equal to x plus 6. Alright, in this case, I must start by distributing the 2 to the x minus 5 to get rid of the parentheses, and then I can proceed to combine my like terms. So let's distribute the 2 initially. So after distributing the 2 and getting rid of the parentheses, I have 2x minus 10 plus 3x is equal to x plus 6. Well, now we can group like terms together on either side. So after doing our combining of like terms, we end up with 5x minus 10 on the left is equal to x plus 6 on the right. Okay, now I want to get the x's together on one side and the numbers on the other. Okay, so what am I going to do? Initially, I'm going to subtract x on both sides because I want just to have x on the left. Alright, and that's supposed to be an x. And if I subtract x from both sides, what do I get? So now, after getting down to the point where we got 4x minus 10 equals 6, we'll move the minus 10 over to the other side by adding 10 to both sides. So I got minus 10 plus 10 cancels. And on the right, I got 6 plus 10. So lastly, what we will do is take our 4x is equal to 16, divide both sides by 4. Whatever I do on one side, I must do on the other. So the final solution of our problem is that x is equal to 4. And as I said, again, you can go back and check your answer out with the original equation and see that it does check. So now let's look at yet another example. Now let's look what happens when we have fractions. Let's say we've got x plus 7 over 6 plus 2x minus 8 over 2 is equal to minus 4. Well, none of us like to work with fractions, so we have to get rid of the fractions. So how am I going to do it? I'm going to multiply by the least common denominator. And in this case, that's going to be 6. So if I take the left side and multiply by 6, and take the right side and multiply by 6, and distribute, I'm going to end up with 6 times the first times 6 times the second is equal to 6 times minus 4. And our result is going to look like this. So now, notice the first 6 has canceled, so we're just left with x plus 7. The second, distributing to the second term, 2 has gone into 6 3 times, so I've got 3 times 2x minus 8. And then, of course, equals 6 times minus 4, which is minus 24. Let's clear out the parentheses. And then I'm going to combine like terms. And then I'm going to add 17 to both sides. And finally, divide both sides by 7. Which gives us our final answer of x equals minus 1.